In deep-sea fishing or aboard transport vessels, adverse weather conditions pose a significant risk to crew members, leading to individuals falling overboard. In spite of various resources such as speedboats and helicopters for search and rescues, the effectiveness of these methods is hindered by the limited search area coverage. Consequently, valuable time is lost, reducing the likelihood of successful rescue missions. Additionally, spotting individuals from rescue boats requires extensive human effort, further complicating the process. Therefore, there is a pressing need for an efficient and reliable system that optimizes search area coverage and minimizes human resource requirements. Furthermore, the challenge extends to border security. For monitoring every stretch of the border for illegal crossing and migrant activity is essential. However, equipping every point of the border with cameras for detection purpose is impractical and costly. Instead, manual surveillance is relied upon.
Now talking about the hardware, there are two main components. First is the autonomous drone itself, and second is the ML based attachment. So let us first talk about the drone. The drone is flown by RD-copter flight controller, which is connected to GPS module. The flight controller is connected to 4 ESCs. The 4 ESC controls each BLDC motors, which are 2200 kV, and there are guards for safety. Then we have a buck converter to change the voltage from 12 to 5. Now let's talk about the attachment. The attachment module is fully detachable. As you can see, there are 4 main components in this. When the person is detected from the Raspberry Pi, it sends signals to ESP32. ESP32 takes the current GPS location and then sends that GPS location through LoRa to receiver. A receiver will receive it, and it will display it on the LCD screen. As you can see, longitude and latitude. Then there are 4 switches which will control the attachment. You can change the position of the gripper and change the camera angle with the switches. When we click it, it also gives feedback that camera angle is changed or camera angle is at higher level. Then the user can also connect the receiver to a mobile application.
So there are multiple steps in order to create a custom machine learning model. So the first step is collecting data sets. So we have uploaded over 4,000 plus images in order to train the model into detecting a person. Second step is annotation, which is basically drawing bounds across the person, and we have used label IMG software in order to accomplish this task. So now we have created data sets, and we've generated the machine learning model using TensorFlow. And once the model was generated, we have converted it into TensorFlow Lite in order to make a better lightweight program. Since we are using Raspberry Pi 4, in order to make it more accurate, we have employed pre-trained neural network model in the form of graph opt.pb. So basically this pre-trained model will help us in human pose estimation. So this neural network model is basically maps all the major landmarks of human body, such as shoulder joints, elbow joints, knee joints, and it will map all this, link all of them together, and this will help in tracking the whole human body and tracking the pose, position and orientation. So once the landmarks are marked across the human body and the pairs are generated using the training model, a signal is generated which says the person is found.
As you can see, the coordinates are the person was detected and coordinates were transmitted to the receiver module, and you can see it on the app as well. The coordinates are transmitted to the receiver module, and you can see the longitude and latitude even on the phone for remote monitoring. Now you can use these coordinates to locate the location on the map.
There are various applications of this project, while we are mainly focusing on 2: border surveillance and search and rescue.
So let's understand how SkyGuard will help in search and rescue. When the person is fallen overboard, multiple drones can be sent to the location to cover a large area in short time. Once the person is detected, the control center will get the coordinates so that the rescue process can be initiated. In border security, multiple drones can continuously monitor the border, and if an intruder is detected, they will send the coordinates of the specific location to the command center, which helps the army to take the further action. The drone can also be used for custom applications like pothole detection, geotagging, forest fire detection, wildlife protection, and building inspection.
SkyGuard, which is a project by students of Reva University, as it has been explained to me, is a drone-based autonomous system which is capable of relaying coordinates in real time to a control center. And this will help us in patrolling activities. It reinforces our existing capabilities by adding strength in the way of locating people who may be crossing over areas where they're not supposed to move, or search and rescue parameters where we require to scan a large area. It may be mountains or it may be seas, land and water bodies, to locate people in distress and then get their coordinates to the control and command center.